In this question, we're given some information about a circular model railway track. We connect 12 pieces that are like the one that's shown here. So the assumption being made in this problem is that if I add those 12 pieces, and that they will form a complete circle. So it's a circular model railway track. We have 12 pieces that look like this one. So this little circular arc here, it's part of a larger circle, is 32 centimeters. When we assemble these 12 track pieces, what distance does a toy train travel along the inside of the track? So if this inside circular arc is 32, and we're going to have 12 of those pieces that are going to be put together, it's just going to be 12 times 32, which is 384, I believe. So that's 384, and that's centimeters. So 12 is the number of pieces. This measurement is given in centimeters, so 12 times 32, just confirming, is 384, and that's centimeters. Calculate the radius of the inside edge of the track to the nearest millimeter. So what we have is we've got a circular track here, got an outside radius and an inside radius. So we're calculating this inside radius using millimeters instead of centimeters. So there are 10 millimeters is equal to 1 centimeter. So the number of centimeters, if I have 384 centimeters, notice we multiplied by 384, so multiply this by 384, you get 3840 millimeters. So that is the circumference of the inside radius of this railway track. So that's 3840 millimeters. That's our circumference, and that's equal to 2 times pi times r, and that inside radius is what we're trying to calculate. So this will be 2 times pi times r. 2 is a number, pi is a constant, it has no units, so if we have millimeters on the left, then radius is also going to be in millimeters. It says to the nearest millimeter, so we'll round to a whole number. So I'm taking 3,840. We've done this calculation now a bunch of times. We want to get r on its own, so divide both sides of the equation by 2 pi, and make sure you're dividing by 2 pi, not dividing by 2, and then if you hit pi in your calculator, it's going to multiply instead of dividing. So I've got 3840 divided by 2 times, using the pi button on my calculator, I'm getting 611.154, etc. So to the nearest millimeter, rounding to a whole number, it's 611, and that's going to be millimeters. That's the inside radius. So now I'm appealing to students, maybe to your teacher. No idea how I would estimate the radius of the outside edge. I wasn't knowing whether they were expecting us to draw circles and compare the outside circle with the inside circle, or somehow get a sense of how much further this radius is based on the scale of the diagram. And just to show you that I actually was trying to work on this problem, I created a diagram using the picture that was given in the textbook, and I used some ideas of this drawing program of how you could create circles based on the arc that's given there. And you can see that I've got a difference in the radius there, 13.5 and 14.3, but I have no idea how a person would reasonably come up with that estimate. We know it's going to be more, but how much more, I don't know. Like I said, maybe the best way of doing that would be to use the 32 centimeters that's given there to establish some kind of a scale, and then estimate based on that how far it is across a railway track. I don't know, and for the time that it would take to do this for just one question, I thought, okay, well, I'm just going to leave that one. So if someone has brilliant insight, let your teacher know, let me know, that'd be great, and we will add that information.